Welcome to this series of ML Demystified. I am Dr. Ganesh, including the prediction and hyperparameter tuning, which are more of understanding and making use of the trained model. The training and evaluation itself involve the first 5 steps, which are gathering data, cleaning data to have homogeneity, model building where we choose the right algorithm and train, gain insights, and then do visualization, which is essentially an extension of gaining insights, and we start consuming the model. So in this video we are going to take the first step here, which is gathering data from various sources to understand data. What is data here? What are different types of data? And then where do we get data from, or how do we generate data? So if you remember, in one of the previous videos we told about the data that is used to train a model. For example, if you want to classify a given color as red or green or yellow, you might have different images of red, yellow and green, and you labeled it as red, yellow and green, and then assume you have a huge amount of data. You might have split it into training set and testing set, which we spoke in our previous video. The training data is used to actually build the model, and the test data is used to evaluate the model. Now, this is what the data here. Data is very essential for a machine learning algorithm or a machine learning based model to be successful. So now let me give you a recap of training data versus test data, and also tell you what is a validation data. So training data set is the one used to train an algorithm to understand how to apply concepts. So if you remember, we spoke, assume you have 1000 images in the database. Maybe a 70-30 model or a 60-80 model is used to train the data, train the network, train the model. Essentially, how do we build the model is using this training set, and later we will use the remaining 20 or 30% of data to validate how our system works. And among the training data, we will use a split of that, maybe a 10% of that or 20% of that as validation set to validate the predictive model before we actually do the final performance estimate using test data. So when we say data, what are different types of data that is involved in a machine learning model? Essentially the answer is it depends on the type of the problem you are handling. For example, you want to do a sentiment analysis of how the current political situation of a particular country. You may have data which is text, versus you want to predict the price of a stock price. Maybe that is time series data where the data comes continuously. You have to predict, you have to use that and then predict as a function of time. So let's see various types one by one. Broadly, they are classified into numerical, categorical, time series, and text. What is numerical data? Numerical data are nothing but those which are values or observations that can be measured, and these numbers can be placed in ascending or descending order. There can be two types of numerical data. One is discrete type and one is continuous type. Discrete type, for example, can take only certain values, a discrete amount of values. So for example, number of students attending a particular session today in a class. So if the class strength is say 67, the number can be only a number between 1 and 67 or 0 and 67. It cannot be a fraction, it cannot be more than 67, it cannot be less than 0. Whereas continuous data can be data that can't be counted but can be measured. For example, in our second video we have seen predicting height given weight. That is an example of continuous data because the weight can be a number which is a fraction, so we cannot exactly label the weight, can only take these values. Another type of data is categorical data, which are values or observations that can be sorted into groups or categories. Typically, bar charts and pie charts are used to represent categorical data. Again, there can be two types of categories, nominal and ordinal. Say, nominal categorical data are values or observations that can be assigned a code in the form of a number where the number are simply labels. So maybe sex of a person. Can only take maybe 1 for male, 2 for female, 3 for transgender, something like that. Or color of an eye, black, grey, whatever. So you cannot order, they are not in any order. Whereas ordinal data, you can count and order. The values are ranked or have a rating scale attached. For example, house numbers in a particular street or swimming levels in a swimming pool. The height is actually in an ordered, it's an ordered system and we can count. Now the third type of data is time series data. The time series data is a sequence of numbers collected at regular intervals over some period of time. It's very important, especially in particular fields like finance. As I said, a lot of financial data are time series. Time series data has a temporal value attached to it. So this would be something like a date or a timestamp that you can look for trends in time. For example, we might measure average number of home sales for many years, or a very good example of recent time is the number of corona cases that are coming up over a particular country or a set of countries, or every day, the number of deaths, number of recovery rates. They are all time series because they are all on a scale of different days of a month or weeks. And here comes the text data. They are basically just words. So a lot of time, first thing that you do with text is you turn it into numbers using some interesting functions, maybe bag of words, and then work with them. These are extremely important that we need to even process text data. So there can also be data in the form of images, videos, audios. Now, how do you get data? There are lots of resources or what is called as datasets publicly available. You see many of them here. The UCA repository, Kaggle, India government has an ISRO, a space research based datasets. National Institute of Science and Technology of the US has a bunch of data. IEEE has a data portal. Mendeley has a dataset portal. There are plenty of them. We can go search and find out the right data that we may want. So many a times the data will be available in many of these. I myself have a few data sets published in Mendeley. Similarly, for specific purposes, there are specific data sets. As I said, the India government ISRO data set is specifically on space research satellite data. And PhysioNet is a very famous data set which contains data that are annotated by medical practitioners, which can be used, authentic and which can be used for medical research. So it's available. And for text data, you may also want to use some of the resources such as the public APIs available. For example, if you are tackling a specific problem of, say, Twitter-based sentimental analysis, you may want to use the Twitter APIs to extract data, understand how sentimental analysis, understand what data I want to capture, how do I capture so that I can do my sentimental analysis. Or data processing on news data. New York Times, for example, has an API available. You can find that reference in this URL. When we use public APIs, there are a few things to take care. One is some of the APIs may have limitations on certain aspects. For example, some APIs is set a limit on the rate at which you can make queries, because if too many people are making queries, their server may go down, which they don't like. The more training examples called as the samples you have, the better. So use the APIs to get more data. Make sure number of samples for every class or topic is not very overly imbalanced. So for example, if you are doing a phishing detection, you may want samples of both phishing sites and non-phishing sites in similar number, if not equal. They should not be too imbalanced. Then make sure that your samples adequately cover the space of possible inputs, not only the common cases. Another way to have data is to generate your own set. These are some of the images that we captured for one of our projects in my work. So they are all currencies of the Indian currency 10 rupees, captured in different angle, different color, different form. And this Indian currency dataset is available in Mendeley in my name. Or another example is a dataset that we have prepared for a project on hand gesture recognition of the traditional Indian dance Kathakali. So here are some samples to show variety of background and location and the poster way we have captured images. This dataset is also available in Mendeley. Now, what is a perfect data strategy? The most successful AI projects are those that integrate data collection strategy during the product lifecycle. For example, the data must be built into the core product itself, because every time a user engages with your product, you may want to collect the data, how they engage, feed the data to improve your product. So the more users you have, you can generate more data, you can develop smarter algorithms, which will lead to better products, which will lead to attracting more customers. So with data, AI becomes better, and in some cases like collaborative filtering, it is extremely valuable. Now I came across this particular article. The URL is given in this particular slide, where they speak about data, gathering data and generating data, the data in machine learning and AI. So they themselves say the data collection has various types of data: data acquisition, which can be discovery, augmentation and generation, or data labeling, where based on those which does not have any label, which do have labels, or existing data where we want to improve data and improve model. So I strongly recommend to go to the PDF and then read more about what they are talking about. And they also talk about how do you make a decision. For example, do you have enough data? If you say no, you will go, are there external data sets? If yes, go discover and get it. If no, have a data generation method. Yes means you generate data. No means you can't do anything more. Now, when you have enough data, you go and try to improve existing model. If you need to improve existing model, you proceed with that part. If not, you proceed to the other part. I will pause for a minute so that you can go through this decision flow before I continue. Okay. Some useful references. The paper that I just referred in the previous two slides is a research article here, a survey on the data collection for machine learning, a big data AI integration perspective. You can find the preprint in ARXIV in this URL. I also recommend reading this data mining concepts and techniques by Han Jiawei et al., which is a very useful book to start with when you deal with data. Yeah, it is very useful even in the coming series on pre-processing, etc. So the 5 steps are gathering data from various sources, cleaning data to have homogeneity, model building, selecting the right algorithm, gather insights from the model and visualize data. What we have seen today is gathering data from various sources. Thank you very much. Have a nice day.